not be in charge of this.
Hey, we're recording now, so that's the important part. Do we want to go on to the quiz?
I'm ready for that.
Okay.
Same.
I'm ready for a quiz.
All right, let me pull this bad boy up. Paper. Okay, fitting this in. You're taking a sample size of n equals 5. Oh, I don't want to print the page. Open the app. Okay, there's that. Okay, when you are taking a sample size of n equals 5, what is the shape of the distribution of means? Oh, so are we supposed to go back to that thing that we used during the chapter?
I was just going to ask that. So I still had mine open. So I changed the mean to n equals 5, and then you make it animated, right? How you get it to move.
Yeah.
Let's see. Oh, here's the link. It's up above. The normal probability applet. So don't use that.
Yeah, I clicked on that, but that doesn't seem to help at all for this problem.
No, it doesn't. When you're calculating, remember around. My guess is we would use that other thing.
Yeah. What is the shape of the distribution of means histogram when the parent population is right skewed?
Right skewed means the tail is to the right. Let's see.
Right. I think it still looks normal. Like when you do enough of them, it still comes out normal.
More than 5, is that what you mean?
Like when I did n equals 5, remember how it made us do it like animated again and then animated again, and then later on it had us go back and click 10,000 to show how like over time if you did it, it still comes out normally distributed.
Mm-hmm.
So, I mean, I don't know.
Okay.
It still came out normal after over time, but then if you just do it once, I don't know.
But was the parent population right skewed at the beginning?
I feel like there was a question about this. I'm going to go back and look at the homework really quick. Because I feel like when I was reading about this, let's see. It says.
It says, how does the shape of distribution of, no, that's not it, sorry.
What, yes. Number 3, what is the shape of the distribution of sample means when the data are not normally distributed, but the sample size is large? So if the sample size is large is when it becomes approximately normal.
Right.
But if it's just 5, I don't think it's normal. It still looks weird.
It's not large enough.
Right. Oh yeah, because it was also saying later on that it had to be like, I have to go back and look at the chapter now, but it was saying about how it had to be a certain size. And that's kind of what determines how big your sample size needs to be, because it won't come out right.
It says around 30. A sample size of around 30 is traditionally thought to be significantly large enough to assure that it'll be approximately normally distributed.
Right. So I think if this is skewed and it's only 5, it's still going to be not normal, right?
Yeah.
Right, but so which direction is it skewed to?
Well, if it's skewed to the right, it'd be still skewed
He's
to the
skewed
right.
to the right. Yeah. And when I use the little thing, it that's how mine's popping up too. When I just do 5, it's just
Mine-
like right skewed.
Mine is weird. I don't know what's happening with it. So if that's what you say, great.
I vote for skewed right because it's not skewed left. I'm sure it's
Okay.
not left. Process of elimination.
Sounds good.
Okay, I have so many tabs open, I can't find the quiz now. It's frustrating.
It says when you're taking a sample size of n equals 100, what is the shape of distribution of means histogram when the parent population is skewed right? So it would be normal.
Normal. Mhm.
Yeah. And then number 5, when you're taking the sample size of n equals 5, what is the shape of distribution of means when the parent population is normally distributed?
Normal. Normally distributed. Normal always equals normal.
Okay.
I agree. I like normal.
When you're taking a sample size of n equals 100, what is the shape of distribution of means histogram when the parent population is normally distributed? These all can't be normal, right?
Still be normal. Yeah.
Really?
Yeah, because
Okay.
I think that's sort of the purpose of this lesson. It's saying that, like,
Here are all these options and it's possible.
Yeah, it's like
Approximately normal.
this is why this number is important, because everything that you put in that all seems random and crazy, when you do it this way, it all comes out normal still.
Okay.
I think that's sort of
Well, and in the homework, it's saying like approximately normal, which still counts as normal.
Normal.
Yeah,
So even with 100, it would be approximately normal, but it still counts as normal.
normal. Mm-hmm.
When would the distribution of means be normally distributed? Choose all the correct answers. Which is what we did.
The data size drawn from a population that is normally distributed and the sample size is small, normal still equals normal. Data are drawn from a population that is normally distributed and the sample size is large. Normal always equals normal. Data are drawn from a population that is right skewed and the sample size is small. That would not be normal yet. And large one sample size still equals normal.
So
A, B, D.
Right.
A, B, D, right?
Mhm.
Okay.
But which
Wait,
of the
but
following?
D is right skewed though. Is that still
But
normal?
the sample size is large.
Oh, and that's approximately normal.
Yeah.
You're right. Okay, my bad. I just even said that too, and I'm like, wait, my bad.
Which of the following gives the best explanation of the central limit theorem?
The parent population is normally distributed. The sample the bell-shaped data.
Central limit. Population.
I'm going to go with if the sample size is large, the shape of the distribution of the sample means will be approximately normal.
D.
Yeah.
Yeah.
Use the following information to answer the next 4 questions. Let X be a random variable with the population, whatever that symbol means, equals 10. And the population standard deviation equals 6. Suppose the sample size n equals 36 is drawn from this population. What is the mean of the distribution of sample means? Is this the applet that we need?
I think this is the one where we have to like do the equations. Hold on, let me.
Yeah,
go
it's
back.
the
Mean.
deviation over
yeah.
the square root of it.
This is
Right.
this is the equation.
But except this is asking for the mean, not the standard deviation.
Yeah, we have the standard deviation. The standard deviation is 6. And then
Well-
our mean is 10.
So the answer for 9 would be just the mean.
What is the mean of the distribution sample means? Yeah, because mu is mean.
Yeah. So it'd be 10. I think.
So it's going to be the. Hold on now. I can't find the quiz again.
What is the mean of the distribution of sample means?
Because if you look at question 10, that's asking for that standard distribution divided by the square root of the sample number.
Okay, so I'm going to do 6 divided by 36 square root.
36.
I got 1.
Yeah, because 6, the standard deviation is 6. 36, the square root of 36 is 6.
Right, but isn't it the standard deviation divided by the square root of 36?
And that would be 1.
Right, that's what I got was 1.
And that's the mean,
Mm-hmm.
even though we have a population mean of 10.
I think
It says what is the mean of the distribution sample mean?
Of the sample means.
Mhm.
Ah.
And that question right there, question number 9, is exactly identical to, like in the wording, to 8C from our homework. It says, what is the mean of the sampling distribution of the. So, and that's how I calculated that one, and I got the right answer. So,
Okay, yeah, I think 1, yeah, and that makes sense if you take the standard deviation divided by the square root of 36, and that would be 1, so.
yeah.
but isn't that supposed to be the answer for question 10?
No, that's calculated differently, I think.
What is the standard distribution? What is that? It's the standard deviation. This is the mean.
Wait, hold on. Let me go back and look.
On 8C, what is the mean of the sampling distribution of sample? And that answer was just exactly the mean that was in the story part in 8.
Yeah, so what you're saying is what we just calculated was the standard deviation, not the mean. The mean is just taken directly from the question.
Right.
Yes.
For number
Okay.
9.
Yes, I agree with that.
Okay, so the mean is
So it's 10 and then 1.
And
Right.
then number 10
Right.
has 1.
Say that again.
Number
9
9
is 10. And 10 is 1.
At the beginning of the quiz, it says to put everything in as a decimal. Does that apply?
I missed that. Let me see.
It says, when calculating anything, please remember to round to 3 decimal places, unless otherwise specified. And I don't see it down here, so I just want to make sure we're putting it in right.
Oh, yeah. Well, number 9, we're not calculating anything because it's just given.
Okay.
But I guess on 10, do we need to do point? You wouldn't put 0.0 though, would
no,
you?
because
Because
it's
that's
not a
understood.
percentage.
Okay.
Right. Like, but what I'm saying is you wouldn't put 1.000
Right.
because that's understood.
Mhm.
Okay.
Regardless of the distribution of the population, if the sample size is large and greater than 30, what would the shape of the distribution be? It would be normal.
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 My question is, what is the probability that all of these are normal?
I suppose we'll find out when we answer number 12 and submit
Huh.
Ah. What theorem would justify your response to the last question? The central limit theorem. Central limit theorem is the one that deals with, because the central limit theorem is the one that deals with distribution of the distribution.
Okay.
The other one has to do with the standard deviation, the law of large numbers.
Okay. I gotta get that straight.
I'm gonna have to say that in my sleep.
Yeah, central limit theorem equals distribution shape equals normal. Law of large numbers equals standard deviation becomes smaller.
Law of large means small. Okay.
Yes,
Great.
there you go. Small standard deviation, yes.
So 12 is central limit theorem, right?
Yeah.
Yeah.
All right.
Got them all. Good job, guys.
Woo!
Yay!
I feel like this week, well, at least this part of the first week was easier than last part of last week because, oh my gosh, that was getting hard.
Yeah. I think last week for me was I'm no good that late at night because I woke up I was like, you know what, I'm just gonna sleep on this and I'm gonna come back and look at it like tomorrow afternoon. And I looked at it the next day in the afternoon. I was like, oh my gosh, I was like making all these stupid errors, like little things I was doing wrong.
Yeah, I took the number 5 homework quiz and I was like, oh yeah, I totally aced this. No, oh my gosh, I got like 60. And I was like, what is happening? Like I didn't even know what I was doing. And I had to like watch all those videos like 6 times to understand what they were saying.
Yeah, it was getting intense, I think, last week.
Yep.
It got intense fast. I was sitting there thinking, oh my gosh, is this going to get progressively is it going to go on this same track? And then by the end of the class, I'm going to be pulling my hair out or what?
Right.
So I am kind of glad it reeled back in a little bit this
Seems
week.
very inconsistent, that's for sure.
Yeah.
I suppose that's okay though, because then we're not always stressed out.
Right.
Yeah. So have you heard, is the exam for next week, is that one of those you can save and come back to, or is it just one sitting? You have to finish it at that
I
point.
think it's a
know
one
that.
sitting thing.
Okay.
I don't know.
I think I'm going to take a day off from work. I'm just going to start in the morning, stay there.
Man, I wish I had that kind of like PTO.
Yeah. Me too. I wish I could just say, okay, kids, mom's taking the day off today. So if you could just please go find something else to do now.
Right.
Right. And I'd have to say to my doctor, I'd be like, sorry, I can't come in today. I have to do like biostats quiz or like test or exam or whatever. And he'd be like, okay, but like all our patients. And I'm like, oh no, we'll just reschedule.
Yeah.
Oh,
Right. That's funny.
All right. Well, I'm going to let you guys go. Good night.
good night. Bye.